Okay, we're back. So pair plot didn't load, so we're going to try a slightly different version of that just to visualize those correlations. So we're going to instead do a heat map. So under our useful Seaborn framework, there's a function called heat map, and we're going to feed it something which is the correlation matrix of our data set. And again, might seem a bit magical, might seem like a bit of a trick, but all these ones you can always find online to learn more about specifically how they work. That's how a lot of coding is actually done. All right. So what do we see here? This looks like sort of an interesting thing that we're looking at. What you can see is basically all of the columns in both axes, and then you see this sort of like pattern from black to white, and it sort of goes orange, red in between. So what this is showing is a heat map of how tightly are these different columns correlated. And since the plan here was to look at churn, if we kind of look at this pretty closely, we're just going to focus on this row. So this is churn here, and now we're going to look at the different columns and how closely do they correlate with the client either basically leaving or not leaving. So black means there's basically no correlation at all. And what we can see is voicemail messages do not correlate. Okay, what else does not correlate? Voicemail plan, and then international calls, okay? So these have no correlation to churn. But then what is sort of closer towards the white? Well, obviously churn itself correlates 100%, but then there's a few interesting ones here. So if we look at this, this is total day minutes, okay? And this is customer service calls, and this is international plan. And this one is day charge. Okay, so we have sort of 4 columns here that seem to have some correlation with people that are leaving. So, okay, so people who use a lot, so they call a lot, that seems to have a correlation. And then customer service calls, so I guess people who are calling in and complaining, and then international plan. So you sort of starts to build a picture of, okay, there's something funny going on with basically customer service, international calls. So how can we sort of dig into that a little bit more? So why don't we just run another one of our nice little plots and just look at, again, a count plot, but this time we're going to look at just the customer service calls to see like what does that data actually look like. So let's see if I get this column named correctly, customer service calls. And let's see what it shows us. Okay, so this seems to sort of say that very few people call more than 5 times. So, you know, there's a lot of people who never call, quite a lot of people who call once, twice, but then it sort of drops off. So you can sort of imagine intuitively what's going on is you know, once you sort of make more and more calls, it's not working out for you, there's some issue that's not getting solved, and you sort of give up at that point. Now, okay, so we've established that there's some interesting stuff going on here, and what we could try to do is then maybe correlate a few of these just to understand really the full picture before we start training anything. So if we assume customer service calls and international plans are somehow connected, why don't we try to visualize those 2 together? So bear with me, this is a little bit longer. I'm just going to do a bar plot, but we need to basically add both of these columns that we're trying to address. So I need to get these columns correct. Customer service calls is 1, and then we're going to do y-axis is going to be international minutes, and then again we're going to just feed our whole data set into there and see what comes out. Okay, actually, we need to make one more adjustment to basically show clearly churn by color, so we kind of understand more what's going on with this correlation. So let's add churn as sort of the third column into this, and hopefully that'll give us a clearer picture. So again, while some of these operations that we're doing might seem a bit surprising, these are all commands that are typically used and you can learn about easily online. All right, so again, we have the customer service plans here on the x-axis, and as we can see, there's kind of some sort of correlation between churn and non-churn. Okay, so basically what we're seeing here is people who have a lot of international minutes are quite persistent, but then something happens here in sort of the 7th, 8th, 9 customer service call where suddenly the blue line drops off. So what does this mean? This basically means that once you've gone through 7, 8, 9 customer service calls, you're definitely giving up. So there's basically no clients left. All clients who've called 9 times are then, after that, they're done. They're finished. So clearly, this is an issue, and it probably relates to international minutes because that's consistently high here. Okay, so again, these are just different tools you can use to sort of do a bit of detective work on your data set. But I think we're ready to try and actually teach an algorithm to try to use these correlations to predict whether or not people are going to actually leave or not. So why don't we jump to that part? So there's a few slight manipulations we have to do to the data set to get there. So one is we might want to drop off extra fields that we have here. So things that don't really correlate, there's not really anything going on, we could drop out. And then the other thing for any machine learning is we'd want to drop off at least the state column, because again, the type is not something that, like, a machine learning algorithm needs numbers. It's not going to learn anything from the labels for different states. So either you would have to encode those or you'd have to drop them off. Just for simplicity's sake, we're going to drop those off. So we're going to remove a few columns first. And the way we do that is we basically reassign our data set, but we use a drop command to choose which fields we don't care about. So those are going to be phone, don't need phone numbers, they're not correlated, area code, and then finally the state. And what we're going to additionally have to add here is access. So this just means we're dropping whole columns instead of individual rows. That's all that does. Okay, now if we do another df info, we'll see that we should have lost a few of those columns. Yeah, so a little bit shorter now, and all numbers, which is again important for the training. All right, so the other thing we have to do is separate out the labels. What are labels? Labels is the thing you're trying to train for. All the others are inputs. So labels means that this is the thing that I'm most interested in predicting. So in this case, for us, it is churn. So we're just going to create a new little mini table, if you will, that just contains the values for churn. So we're just going to use that one column and create this new table called labels. Okay, easy peasy. Now, since we already have the labels separate, we're going to have to then go back and actually remove that from the other data set, because this other data set is what we're going to actually use for the training itself, right? That makes sense? So I'm just going to do that and drop it from the main data set here. All right. And now the next thing we're going to do is use some machine learning. So all of this up to now is just basic manipulation, exploration of the data. Really, the machine learning part is actually more simple. This might seem a little bit hard up to now with all the sort of detective work, but that is why data science is not just about sort of neural networks and really advanced, deep learning. It's about actually understanding the data. That's first and foremost your job as a data scientist. Okay, so now we get to perhaps the sort of more interesting or kind of fun part. So the first thing we're going to do is split our data set between training data and validation data. What is the point of that? So the point of this is to make sure that if we're training our algorithm, that it's actually has some test data. We want to train with part of the data to sort of tell the algorithm what to do, but then we want to sort of make sure that it's actually working. So we need to have some extra data left over that we can test with. That's all. And there's some useful methods that we can use again from our fancy frameworks that sort of automatically randomly pick out test and validation sets from within our existing data. So there's a function called train test split that we're going to need. And then we're going to establish these different variable names for these different parts. So again, this xtrain, xtest, these just mean basically the inputs. So input, training inputs, testing inputs, and then separately we have ytrain and ytest. And you might wonder, what is the purpose of x and y? This is just sort of machine learning lingo that's being used. These are effectively just inputs and labels, nothing more. Okay. So we're calling our train test split function with our data inputs that we removed our labels from. Separately, we're putting our labels, and then we're just going to use a parameter here to set how much of the data are we saving for testing. So we're going to save 25%. Now let's see if that runs. Okay, no problem. And now we're just going to train a classifier. So we're going to try decision trees. This is a very simple form of machine learning. There's many others, but typically decision trees are one of the first ones you would try because they're very straightforward, fast, and simple. So we're going to train our decision tree here. Simple as that. So now these commands are basically going to create a decision tree classifier. And then we're just going to train the data. So that is as simple as calling a function called fit, which does the training. Okay, so we're going to feed our training data. And there we go. It's done. So we basically now have done some machine learning training. The next thing we're going to want to do is actually figure out what actually happened. Does it actually work? So we're going to have to do a bit of evaluation, and there's a few different methods we can use to do that. So one is called score. So we can just call our classifier or our machine learning model, if you will, and just test how accurate is it on the training set. Oh, small mistake there. Okay, 1.0, since this is percentages, 1.0 basically means 100%, so it's 0.1 would be 10%. So basically it's perfect because obviously that's the training data set. So why don't we try it on the test data set instead? Let's see how that looks like. So I'm just changing the different splits we had. Okay, 90%, not bad. So now, really, there's a few different evaluation methods we could look into, but really to kind of just close it off here for the sake of time, how do you use a machine learning model? So all we really need to do is take some inputs and call our classifier. So the way that works is if we take this function called predict, and we just choose one of the rows in our data set. There's a function called index, so we can call, this is basically row number 2 out of our data set, and then we'll predict whether that particular client is churning or not. Oh, slight issue there. Let's see. Okay, so what does 0 mean? 0 basically means no churn, right? So you could choose any specific row out of the entire data set, and you can test whether this is actually gonna, this client is gonna churn or not. That's the idea here. So as you can see, most of these clients are not gonna churn, but out of the 3,000 rows that we have, certainly some will. So, for example, client number 1,000 is going to churn. So this is a person that we would want to contact and try to convince them not to leave the company. So this is kind of an end-to-end demo. Happy to answer any questions and expand on any topics that you guys would like to hear more about. Thank you.